intro about SolidWorks and its features. To start with, I would like to give you an overview on the product development cycle. In this product development cycle, you can notice there are 7 stages involved in every product development. For any product in the market, definitely there must be a need. Because of the need, we will start to create, and that's what we call as conceptualization. And before we go into conceptualization, the first process is we need to have a small meeting where engineers, sales, marketing, and all the people will sit together for a debate, and they will come to a conclusion that the product should have these features, it should have these functionalities, and this is used in this environment. And based on this, you will have a small conceptualization, that is, it may be in a hand-drawn 2D sketch, or it may be in a 3D view, or it may be a small prototype of the entire product or a partial of it. Once this is completed, they will go for the next process, that is design. And here, using mechanical application software, they will do the product design, and also they will do assembly. And once this is completed, and the next stages, you have to validate. It means we have to give them assurance that this product can work in hottest place and also in coolest place. An engineer who is involved, or an engineer, or I can say a person who is involved in designing a CPU, he must give an assurance that this CPU can work in hottest climate and also in the coolest climate. And this is what every engineer has to give an assurance, and that is what we are doing here, that is, we are validating the product. And once this validation is completed, the next stage is we want to give them the details of the product in production documentation, that is, we want to give in orthographic views, sectional views, and also 3D sectional views. And once this has been completed, now using this, the labor or the worker or the employee will develop a program, and based on the program you will go and produce the product. And nowadays this process is also involved using software. And once the software is used for manufacturing, definitely you can reduce the time involved by reducing the unwanted travel of tool, and you can avoid the cost by reducing the accidents, and also you can use optimization process, which can tremendously reduce the work or the time used to create the entire program for machining the product. Now the next stage is visualization. Once you completed the product using a manufacturing software, the next stage is you would like to show your product in more realistic, so that the customer will attract in the first sight itself. And this is what the entire product development cycle involved in any company, and they will do all this using different softwares to develop the product. But when you learn SolidWorks, you can do all this in one single platform. SolidWorks has an interface where you can do sketching, modeling, validation, simulation, as I told previously, and also you can do the product data management, that is, collaborating with different engineers working in a small work group. And that's all about product development cycle. And now let us know a small view on the different software trained in CAD Center for different type of areas. Definitely every engineer will be eager to know about this process, that is the different software used for different type of application which is specialized in those areas. As I said previously, SolidWorks is capable of doing all this process, but still there are some software which is most capable of doing those kind of operations. The first process, as you know, conceptualization, and once it is completed we go for sketching, that is 2D sketching. For 2D sketching, the most popular software used in most of the companies, AutoCAD. And for computer aided designing, we use, or everyone has to use, SolidWorks, ProEngineer, NXCAD and CATIA. Now there is a question, why we need to learn multiple modeling software for designing a product? It is very simple. As I said, SolidWorks is most capable for small and medium scale enterprises. When you think about you want to enter into large scale or any type of industries, or it may be you want to design any product range starting from large scale, small scale, medium scale, definitely you should know different platforms. And that's why you have to learn SolidWorks, ProEngineer, NXCAD and CATIA. And computer aided engineering, where we will be doing the validation. That is, we are going to apply boundary condition and we are going to find out the stress distribution or pressure, or it may be deformation of any product. Here we use ANSYS, NX Nastron and Pro Mechanism. And last, with manufacturing we use NXCAM and Pro Mold, which is entirely giving solution for tool design and also for machining. And that's all about product development cycle. To make it one more time to make it more clear about what we discussed previously, we started with the product development cycle, and we had seen a small intro about the different software used in different areas, and now we are going to start with features of SolidWorks. As I said, SolidWorks is used in most of the industries. Now definitely everyone will be interested to know about the features in SolidWorks. The first one is feature based modeling, which is common in most of the modeling application. What do you mean by feature based modeling? Feature based modeling is, now you just look into these images, process 1, process 2 and process 3. What we're doing here, we are going to create a block with a hole, and also the 4 corners has to be blended. And if you want to create these type of model, the first process involved is creating a block, and we are blending all the sharp corners. And third process, we are going to make a hole, and this is called as feature based modeling. Feature is nothing but a building block in a geometry, and as you know, geometry is a easily understandable shapes, and this is known as feature based modeling. The next feature is parametric design, which is the most requirement for every mechanical engineer who works in a company. And here, what is the meaning for parametric? Parametric is nothing but a model driven by variable dimensions. Here we have an initial model, which is a cylinder head, which is used in engine. And here the first image, you can see the initial model, you can see there are 4 holes. Now I would like to increase the length of the cylinder head. Now when I increase the cylinder of the head, or when I reduce the diameter of the hole, you can see the other design intent is not disturbed. And you can see in the third image, where you can see the hole size, once again it is reduced, and there also you can see there is no design change in the other geometry, only the hole has been changed. And this is what we call as parametric design. It means the whole geometry, where you can see number of features, every feature will be parametrically related, and if you change any one feature, only that feature will be changed, other design intent will not be disturbed. The next feature is bidirectional associative, which is more interesting in SolidWorks. You do part and you do modeling, and once you complete the assembly modeling, you will go for creating the production document drawings. And what you see here is exactly the product, that is the production document drawing. The first image will show you the part created, and the second image will show you the part is used for creating orthographic views. Now the situation is, the engineer will create the first connecting rod and he will go and create orthographic views. So these are two different separate files. Once he designed and he goes for creating orthographic views, now there is a small feedback from the assembly department says that all the sharp corners has to be blended to avoid the sharp corners, so that it will not damage the users. So if he had this feedback, and now if you want to modify the sharp edges, he will blend it using a command called as round. If we apply the round immediately, that will be reflected in the drawing also. This is what we call as bidirectional. And if you reduce the hole size, it will also reflect in the associative drawings. And moreover, if he changes anything in the drawing environment, that is in the orthographic views, it will reflect in the part and assembly. This is what we call as bidirectional associative. And now these three features is common in almost all the modeling software. Now I would like to show you the unique features, or I can say these are the salient features in SolidWorks. The first one is graphical user interface. Graphical user interface, you may be surprised what is about it. Every user will be having a small knowledge on MS products, such as Microsoft Office products. SolidWorks is also having the similar environment of MS products. So the user who want to learn the software can easily adapt to this graphical user interface. The next one is easy migration from 2D to 3D. So what is about it? Now a company is using a 2D software for a number of years, and now they want to shift from 2D to 3D. What they will do it? They will look to a software where I can understand my conversion of 2D to 3D as simple as possible. Here SolidWorks, which is capable of doing this process so simple. How? Definitely we will see in the later session. And the next, process specific features. There are two components. One is phone and one more is calculator. And if you look into these products, there are some specific features where you will be using frequently. Example, there is a hole we call as vent hole, and there is one more mounting used for assembling two components. And here you can see the shape will be having a lip. There will be an option of using a provision to assemble two components. To create these type of plastic components, we required some specific features where you don't want to create it. You can just call the feature, you can place it there. This is what we call as process specific features. The next one is SolidWorks Task Scheduler. The biggest advantage with the SolidWorks Task Scheduler is, now there is a situation. You have a task of updating all the part files which is done in SolidWorks 2008, and you want to convert these 2008 files into 2010 files. Now the typical situation, what you will do is, you will open the files one by one and you will convert or you will save it. But using SolidWorks Task Scheduler, you can do it as simple as possible. So what you will do here, we used to open a separate task scheduler application which comes with SolidWorks, and you will show the path where this file has to be converted. So this will be converted into the new version which you want to do it. So this, you don't want to require the manual input. You can give a schedule time, starts with 9 o'clock, end with 5 p.m. and also you can do some of the process like printing the documents and creating drawings automatically by using templates, etc. You can do all this using SolidWorks Task Scheduler. Next, Toolbox. SolidWorks Toolbox will give you standard nuts, bolts, washers, spring, and then split pin, and apart from that you have power transmission, that is you can also get spur gear, helical gear, bevel gear, rack and pinion. All this will be available in SolidWorks as a library. You can retrieve and you can use it wherever required, where you can save a lot of time involved in creating this standard components. Next, one more thing is advanced commands. When you look this product, I hope you know this is a speaker, and this speaker you can see it looks so stylish, where you can see the features are blended and it is twisted, it is rotated. And now if you want to create these type of features, definitely you have to create the product using advanced commands, where SolidWorks will use commands like freeform, where you'll be able to drag the surface and you will create an like a clay modeling, and you can also twist, blend, whatever you do, you can do it here using advanced command. And next, one more thing interesting, PDM, that is product data management. As we know, the world everywhere we are involved in globalization, and every company is required to do this process, and that's why PDM is more important, because we should know how to manage the different data available with the different peoples, and that has to be collaborated. And that's entirely what we are doing. We are going to see in product data management. You will have a centralized vault, that is we will use a server machine, and these different processes are done in different locations, and these different locations will be accessed through the server, and all will be collaborated together to complete the project. And the next, I will go into FLUENT. This PDM will be a separate module, which is an application which runs inside SolidWorks, or which can run as a standalone application. Definitely we will see this PDM in detail in later session. And next, one more thing, FLUENT, an image which shows an automatic robotic system, where you can see number of structural members. As of now we are seeing only single product design, but once you complete single product, definitely you need to assemble all this product in an entire structural member, that is you have to do it in a framework. This structural design fabrication assemblies, definitely you can do it using SolidWorks in a user-friendly way. If you look into these type of assemblies, the first primary requirement is we need the information about the cut list, that is when I create the whole design, how many structural members I will use here, what is the length for the individual members, and all this you can achieve as simple as possible in SolidWorks. And with this, I would like to end up with the various products available in SolidWorks for design, managing, that is management, analysis, sustainable design, communication, free CAD tools, and free 2D and viewer tools. I'll give you a small view on this. Design, that is for creating 3D models, managing the product data management, analysis where you will do validation and also simulation, sustainable design which is specifically focusing on a design where you will reduce the usage of material, thereby reducing the carbon footprints, which is most necessary for every engineer to know before they produce any product. Communicate, it is without the Solidworks software, you can communicate your ideas using 3D via composer, where you can show them more realistic in nature. Free CAD tools, which makes the engineers, the students who want to design their products can download all this application which is available in SolidWorks website for creating, for sharing, for editing the designs. And the next one is free 2D and viewer tools. This is especially when the customer is not having the software, they can download the software which is free of cost and is used for just viewing the components or viewing the assembly or viewing the product documentation using eDrawing viewer or using 3D via composer. And that's all about SolidWorks features. And now let us look into SolidWorks graphical user interface. A graphical user interface of SolidWorks is so user friendly where any engineer, any design professional can work closely with their component design, not much concentrating on the software. That means you can create the products simply better using SolidWorks. To start with, I would like to show you where is the feature manager tree, which will have the history of the whole model, callouts and handle, which makes our job easier, confirmation corner to complete any task, and using mouse buttons, reducing the mouse travels, and different keyboard shortcuts in reducing the time taken to create the product, and a centralized command manager where all the commands can be retrieved. And finally, we are going to see an application where you will be able to understand your computer, your PC is able to satisfy the SolidWorks requirement. Means your hardware is exactly matching with the SolidWorks application. Now let us jump into the SolidWorks application. This is the graphical user interface of SolidWorks. Here, the first thing I was saying about SolidWorks is exactly similar to the Microsoft Office products. Here you can see feature manager tree is located here, and this is centralized command manager, and when you select this tab, all the commands will be dynamically updated. And the one of the interesting factor is every command will have a small text over the icon, which is easy for the user to understand which command icon is used for the feature creation. Feature manager design tree. Feature manager design tree in SolidWorks is useful in retrying the product design. Now I need to understand the plane called as right plane, where it is located. What I can do is simply I can go to here filter, and if I type here as RIGHT, only that plane will be highlighted, so that it will be easy for me to select, and using this call out I can use the sketch icon to sketch the profile. Now this is one thing interesting about SolidWorks. Okay, so what is the advantage of doing this? If there is a big history and you have nearly 1000 commands or nearly 250 commands, and exactly if you want to know the command where it is located, you can type simply in the filter and you can do the command editing. And apart from this, in this feature manager design tree, you have properties, configuration manager, and you can also have dim expert manager and display manager. And there is one more interesting factor. If you are an AutoCAD user and you want to use same like command prompt for SolidWorks, all what you do is go to tools, you have here add-ins, and you need to activate SolidWorks 2D emulator. And if I activate this SolidWorks 2D emulator and if I click OK, now you can see it will show you command prompt where you can type the command which you require to create. Now I will type the command L here and I will enter. Now it will prompt you to select the plane. I will go and select a plane from this location, select the stop, and now you want to the command is not activated. What I will do here, I will go and say F8, and which is used for orienting the plane. Now this will not be customized for this environment since it is in 2D emulator. What you do is right now I'll cancel this. This is what we call as confirmation corner. Whatever the command you execute, you want to confirm it or you want to exit, you want to use this confirmation corner. And I will discard the change. And now the next step, what I will do is I need to create a sketch. I'll go to front plane, I will use this call out and use sketch. And after this I'll go to the one more flyover toolbar. Here I will use normal to view, and once you do this, you need to go to any one of the command from this command manager, and I will select this line and you can draw this. This is choosing the icon, or if I want to follow the AutoCAD methodology of typing the command, here I can go and say L, enter, and from point where you don't want to use once again the cursor, I can type 0, 0 and enter. Now the first point is generated and at the rate of 100, 0. Now you can see the second line is generated. This is how you can use SolidWorks as a so user-friendly environment, both for sketching 2D and also for creating 3D. That's all about feature manager tree, SolidWorks 2D emulator, and then confirmation corner. And now I would like to deactivate my 2D emulator. I will go to SolidWorks tools, add-ins. I will deactivate this. And now let us look into one more interesting factor, that is we should know how can we orient the views. To get different orientations, you can use either the triad, or what you can do is you can press space bar, you will get this orientation box, and you can use this to pin the box. And now if I select isometric view, trimetric view, diametric view, whichever view you need, you can orient as per the need. And once you complete this, you can go and apply the command. To know using the handles, now I'll use extrude command. Here you can see the handle. This is what we can do. This is what we call it as handle. Using this handle, you can exactly enter the value which is required for this sketch to be converted as a solid. As a whole, if you look into the graphical user interface, it is so user friendly for us to understand SolidWorks software. And the commands, once again, you can retrieve from the menu bars. And also there is one more advantage we have here, that is you can customize according to your need. Now what I'm saying is, now I need a command called as circle using a shortcut WO. Can I do that? Yeah, you can do that. What you need to do is right click in this area, go to the customize, and here we have keyboard, and using this keyboard tab, here you enter, or what you can do is you select first icon. Now it is given as N control plus N is equal to the shortcut. Now here you can see I assign some of the shortcuts here. I'll select for circle. You can see here defaultly there is no shortcut for circle command, but I assigned as O. This is how you can now. We'll see in one example. I'll go and say perimeter, and here I will say control plus 0. But it says once again it is there for the open file open. I will cancel this and I will say control plus H. Now I assign control plus H and click OK here. And now the next step is I will use control slash. Now you can see it is requiring a plane to sketch. I will use this face. Now you can see the circle is in process, but this circle is not a center point, it is perimeter circle. That is, you have 1 point, second point, and you have third point here. This is called as perimeter circle. So it's once again we need to use confirmation corner. Now we create a circle on this face, and this is all about customizing the tool with respect to the keyboard shortcut. And this is all about SolidWorks graphical user interface. And at last I would like to show you one more advantage we have here, that is when you work on more complicated design, we need the same graphical area to be in 4 different views so that it will be easy for you to design the product. This is what the 4 different views, and you can rotate this model here, and you can see here if you do any modification here, say I will just select this and I will say this has to be relocated up to here. You can see here it will be dynamically updated in the 4 views. And once again you can go back to the one single window and you can see the product design. And this is all about the graphical user interface. And at last, the one more interesting feature, that is search commands. You are new to SolidWorks, or you are using Solid for a number of years, but still you have forgotten any one command, but you know the starting of that command. It doesn't know where it is located, or you know a software called as AutoCAD, where you will use a revolve to create an wheel or cup shape components. Now you want to use the same command in SolidWorks. What you can do is you can go and type here as REVOLVE, revolve, and if I select this, now you can see the command will be automatically executed here. And this is all about SolidWorks graphical user interface. And apart from this, we have a number of utilities, enhancements in SolidWorks, like using the mouse, and you are using the this fly toolbar, and we are using different type of enhancement in manipulating the views. And that's all about SolidWorks graphical user interface. Now everyone will be interested to launch SolidWorks in their desktop or in PC. To launch SolidWorks, go to Start, All Programs, SolidWorks 2012, or you can click SolidWorks 2012 icon in your desktop. And to open a new file, you have to go to File, New, and then select the template available in the dialog box. And third, you need to set up unit and standards for your file. Now let's see how we can do this. Now I had clicked the SolidWorks icon from the desktop. The software is open now. All I need to do is go to File, New, and you can see there are 3 tabs: Part, Assembly, and Drawing. These are 3 default templates available in SolidWorks, and when I select this part, the predefined standards, units, everything will be predefined, and based on that a file will be opened. And now when you need to change the units for the specific file, you can go to this lower corner, and here you can see it is defaultly mmgs, it is millimeter gram second. You can change the units by selecting this Edit Document Units, and here you will get different type of unit system, and you can select which unit system you need, and you can also set up the decimal values, and also you can select if you required dual dimension length. Next, one more thing which is very important for every engineer, setting up standards. Here we are using as of now as a default ANSYS. You can also set up ISO, DAN, Japanese standard, British, and then Russian, and then whatever the standard available here you can choose, and based on that you can draft a view or you can apply dimensions for a part. And this is all about opening a new file and setting up units and standards. And once you set up all this, the next process is we need to go and create a 2D profile or a 3D profile for the future creation. And here you have two type of sketches. One is 2D sketch and other is 3D sketch. So what about this sketch and 3D sketch? Let's have a small view on this. On the 3D sketch, in 2D sketching, what do you do? 2D sketching is the combination of different entities to create a closed profile or an open profile on a working plane or a plane. In 3D sketching, you create entities on a plane or at an arbitrary point. That's what we are saying in we create a line in X, Y, Z direction, or it may be in an arbitrary point. Now let us look into SolidWorks how we can create these two before we know these topics. Where is the sketching tool available? Sketching tool is available in the centralized command manager, or you can retrieve from tools. Here you can see sketch entities, sketch tools. Now what we are going to do is, let us understand 2D sketching and 3D sketching. Go to sketch tab. Here I have sketch and I need to select a plane, and you can go and choose any entity from here to create a closed loop or any open loop. This is one process of creating 2D sketch. Once you create this, I can use confirmation corner to end up this process, and the next step is I would like to create a 3D sketch. Go to sketch, 3D sketch. Now you required a plane to create the 3D sketch. Now what I will do is I will select the default top plane. We need to select the tool, not the plane, for the 3D sketch. I hope you understood what I'm saying. Once you select 3D sketching, you directly go to the command, and now you can start to create. Now you can see the cursor will be attached with a pencil and it says XY. Means whatever you create, it will create on the XY plane. It is not created on the any other plane. I just created here. You can see here the two lines created on the XY plane. Now you need to create on any other plane, you need to use tab key. And if I use tab key, you can see we are creating in the different plane. This is how you can create sketch either in 2D or in 3D. So do I have any example for 3D sketch? Yeah, of course I have this. Now I'll cancel this, and what I will do here, I'll also cancel this. I'll open the recently opened file and I will say this is my part, and here this part, this is a frame used for any conveyors or used for any transportation vehicles. Now I need to create this geometry. How can I create this? I'll delete this feature and I'll show you the path. Here you can see this path. You can see the path. This path is created using 3D sketch, and this is one sample example. Similarly, you can create the entire path required for any racing car, or it may be the entire structural path required for the entire fabrication assembly. And this is the advantage of using 3D sketch. You can create 2D sketch or you can create 3D sketch in SolidWorks, and then you can start to go making components. In SolidWorks, you have seen as of now 2D sketching and 3D sketching. Now let us look into the different sketching process, or I can say another way, we are going to see different tools, entities used to create sketch 2D sketches. It may be closed or it may be open profile in SolidWorks. To create any product, we need sketches. The sketch can be created using 2D sketch tools or 3D sketch tools. Now we are going to create sketches using sketch entities, and using sketch tool you will edit it, and to apply the characteristic for entity we use geometric relations, and we will use dimensions, and we are going to diagnose the sketch whether it is possible to create or add feature for the sketch, and finally we are going to validate the sketch whether it is fully defined or it is partially defined. These are the different commands and topics we are going to cover in sketching of SolidWorks, and all these tools will be available in the command manager of SolidWorks. You can see here a clip of that view is shown here. To start with, we will first see the command line. Line is nothing but the shortest distance between 2 points. Here you can create a line in required direction, and you can create an horizontal line, vertical line, an angular line, and apart from that, when you create a line you will get an inferencing line we call as tracking. In AutoCAD you call as tracking. The same you can get in SolidWorks. So it means that the sketching is more user friendly and easier for creating any type of sketches. It may be easier, it may be complicated. Let's see how we can create a sketch using a line command. And now we are in the sketching environment, and I'm going to sketch on the front plane. I'm going to sketch on the front plane. Go to tools. You want to get a line command, go to tools, sketch entities. From here you can choose line. Here I said we have orientation like as sketched, horizontal, vertical, angle. Select the first origin here, second origin, how much you required. You can just go and create this. I require line of this, but it says 81.96, but I'm not able to create exactly 80 or 90. If there is any option here, yeah, of course. Let us first finish this first line segment, and I'll give escape to exit the command. If I once again need to execute the command, you can use enter key to retry the last command. And now I need a vertical line, and I can select the line from here. Before that, I will enter the value as 60 here. And from here I set the first point, and you can see a vertical line of predefined 60 will be created. I'll give escape. Now once again I need to retrieve the line command. I'll go and select L from the keyboard, and I'll say vertical, horizontal, whatever you need you can enter here, and once I enter the value, accordingly it will be created. But I need an angular line to create. First I'll complete horizontal line, and I'll create angular line. Give escape. I'll go to line command, angular line, and here I will say add dimensions. It is selected automatically. If you need, you can select or deselect it. I'll say 50 or I'll say 30, and the angle is 25 degree, or I'll say 50 degree, and select the first point and second point. If you give the second point, it will ask only direction, or some direction. You can see the sketch will be given with dimension, and also that is linear and also angular dimension. Now this is the sketch created using line segment. But once you are creating a line, you can also have the advantage I said inferencing. That means I want to create a line. You can see here it shows an yellow color line which is called as inferencing. You can draw parallel to this, or the line command is followed with OR command. If you want to switch this, I can select a Now you can see it once again it is switched back to line command. And there is one more thing I want to highlight here. When you create a line segment, you can also create an arc continuing with that. Before that, let's complete this inferencing. You can see here when I move near to any of the line segment, you can see here it will show you the end point, or I can drag from here to get this midpoint. I think now it's getting here you can see midpoint from this line segment. I'm getting this. Okay, now what I will do from here, I will show an example. From here I will get a point from here, and from here also you can see a midpoint. You can choose from here. So this is what we call as inferencing point. And once you complete this, if you want to continue with an arc with the line, I can select A from the keyboard so that it will automatically switch to arc. Or if you move cursor near to the line segment, you will get the arc command activated automatically. And now after the arc completed, once again start with line command. Now the line has been created, the entire sketching process has been completed. This is all about a line where you can create horizontal, vertical, as sketched, and also angular line with dimension and linear dimension. So it is angular dimension with linear dimension. And there is one more advantage we have here, that is you can create a line segment for only construction purpose. Means I want to create a line which should be used as a construction purpose. I can set a line which is showing as a construction line segment. And there is one more advantage line command we have, infinity length. If you use infinity length, you can say I want to create a line segment which can be used as an which will not have the start and end. And this line once again you can convert as a construction by choosing this option from the line properties. So using line command you can create 4 type of lines, and also you can create infinity length and also construction line segment. This is all about line command. Rectangle. Rectangle, as we know, it is a 4-sided polygon. In SolidWorks we have 5 types of rectangles. One is you can create a rectangle using 2 diagonal points, or you can choose a center point and a other corner. You can create 2 ways of oriented rectangle, and fifth you can create an parallelogram. Now let's see how can we create these rectangles in SolidWorks. Here the different type of rectangle can be retrieved from this pull down. I will choose a corner rectangle, and you can see here this dialog box will give you 4 types of rectangle. The first one is corner rectangle. I can choose, I'll go to corner rectangle. I will choose, now the corner rectangle is in active. I can choose the first point, and I can say second point up to here. And there is one more command, that is center rectangle. You can just select the first point, and you can see the rectangle will be exactly centered between this point. It is symmetrically distributed. And the third is you want to create an oriented rectangle. You can do this. First point and second point, this is the orientation angle. You can see it gives you distance, it is length of this rectangle, and angle is 25.83. And moreover, you can see it gives you the tracking point where you can exactly see it is exactly matching with the midpoint of the bottom line. And now I will select the second point, and now the direction is moved here, and that distance d is equal to 23.98 is showing the width of the rectangle. Draw this. Now the oriented rectangle is finished, and once again there is one more challenge. I need to create a rectangle where it should be exactly centered, but it should be oriented. Now I'll select a point from here. That is, I'll take this point, first point, and select the second point from here, and now you can see we'll get the midpoint using this tracking, and I'll select how much angle you need, and I can choose a rectangle here. I can create this rectangle. And last is I would like to create a parallelogram. I'll choose a first point, second point distance is 85.56, and I can choose, you can see here the two lines are parallel, that is width lines are parallel, and I choose a point here. Now we are seeing the 5 type of rectangle created in SolidWorks, and this shows that the SolidWorks is giving you number of tools to create the sketches, avoiding the multiple operations. Slot. In SolidWorks, next topic we are going to discuss about slot. Slot is used in many machine components for aligning the other components which is engaged in mechanisms. We have 4 types of slots. First, straight slot defining 2 endpoints of the arc. Defining 2 points for the slot creation. And third, we will create the slot by defining the radius of the arc. And next slot is center point straight slot. Next slot will be created using center point and the 2 defining points. 3-point arc slot and center point arc slot will look like similar, but only the way the point how we input differs. Now let's see this in software. Now I would like to create a straight slot in this area. Let's see how can we create this. To retrieve slot command, I will go for straight slot. Here I have center point straight slot. To engage exactly in center, I will use center straight slot. Select the first point and second point how much you want to extend, and if required you can choose here add dimensions. And now if I choose here and here if I select the point, you can see with dimension the slot will be created. The same like I can go and show one more slot required for chain mechanism. I can just create this by defining 2 endpoints, and once again dimension will be imposed on that. And next let's see how to create the 2 arc slot and center point arc slot. Now starts with 3-point arc slot. You can see the icon, it shows exactly which is first, second and third. I would like to start with the first point from here and second point here, and third point defines the arc radius. And when I drag this mouse, you can see here the arc slot is created. And the same like we can create by different input method also. It is by center point arc slot. Select the first point, second point and third point. I have to rotate in this way, third point, and I'll define this, and now the arc is created. Here you can see we are defining the width for this and radius and also angle. Using this, once again we can control the slot. This is how SolidWorks is reducing the time spent on creating complicated sketch by avoiding multiple operations like trim, extend, and creating one single slot like this. Polygon. Polygon is created by defining number of sides, and the polygon can be created inscribed in a circle or circumscribed about a circle. And we also input the coordinate values, circle diameter, and then angle. And when you need to create additional polygon, you can select a new polygon button in the property manager. Without exiting the command, you can create new polygons. Let's see how can we create this in SolidWorks. I'll go and choose polygon from here, or I can choose from sketch entities polygon, and I will choose the first point here, that is center point of the polygon. And after placing this, I can control the parameters, like I need 6 sides, or I need the diameter, that is inscribed circle dimension should be 80 mm, and angle, if you need, you can enter the angle, how much you want to rotate, but right now you cannot rotate since it is constrained. I'll click OK here. Now the polygon has been created. And next, one more polygon if you want to create, you can see the polygon will be created without exiting the command, and continuously you can create number of polygons, and you escape to exit this command. Now I will delete this. The next, we are going to see creation of arc by 3 different ways. Tools, sketch tools, sketch entities. Here we have circle, center point arc, tangent arc, and 3-point arc. Now I will start with the first circle. Circle can be started from here or choosing from the command from command manager. Now for my user friendliness, I given a shortcut, and using that, now I had retrieved the circle and I'm going to create a circle on this part. Now I need to create a circle. What I will do here, I will go and say a circle has to be created on this way. That is, we are defining a center point and a point on a circle. The next one is 3-point arc. It is perimeter circle. You will define 3 points. First point, second point, and third point. By using this, we can define perimeter circle. To make it more simple, I will say one more application example. Now I would like to create circle, that is, here I have a gear, here I have a gear, and here there is one more gear. I need to relate all these 3 gears using an circle. How can I create this? I'll go for circle command, perimeter circle, first point, second point, and third point. Now as you know, you can select the circle and using this call out define as construction geometry. And same like you have a polygon here, means I will select polygon, I'll go and define as 3, and I'll create a triangular shape over here. And now here I want to create one more circle circumscribed about this triangle. I'll go to circle, which is perimeter circle, first point, second point, and third point. This is the way we can use center point circle and perimeter circle for creating sketches. Now let's see how can we use arc command to create arc based on 3 points. I'll go for arc. First one is center point arc. This is my center point. I would like to create arc starting from here and ending up to here. The next one is tangent arc. Here you need to select only the end point of this line segment, you'll get the tangent arc. The third type is 3-point arc. You will select first point and then second point and third point will define the radius. You can select in this way or you can select in this way. Accordingly the arc will be generated. This is how we can create polygon and arc in SolidWorks. As of now, we have discussed about creation of arc using 3 methods, circle created using 2 methods, and now let us discuss about sketch entities. We have ellipse. Ellipse, I'll select the first point here. Second point, we will define the major radius, it is major axis size and minor axis. The ellipse has been completed. Now there is one more requirement. I need to create an ellipse exactly. It should be hemispherical, means it should not be fully having the shape of elliptical shape. I should create an elliptical arc. That is my objective. How can I create this? If you want to create an elliptical arc used in nuclear reactors. You can go to tools, here entities, here we'll go for a partial ellipse. First point the same, like you have to define major axis, minor axis, and here start has been defined, end point is defined it. Now the arc has been generated. Once again you can control this ellipse using these parameters. That's all about ellipse. The same, like we have a number of entities here like parabola, spline. And parabola, let's see, parabola is nothing but the curve generated when you slice a cone using a plane. If it is parallel to the screen or parallel to the face, we call it as parabola. If it is sliced at angle, it is called as hyperbola. I will choose an parabola here. To create a parabola, I would like to select the first point, and this is the focus point. This is the first point, focus point, and I would like to create the shape by defining 2 points. Now we have defined the parameters for parabola, and this shape is used to create the dome shape required for an headlight, or the dome shape required for an front nose of an aerodynamic shape, or it may be for any race car. This is all about parabola, partial ellipse and ellipse. Let us look into spline, which is called as smooth polyline. Spline is created by defining a number of control points where it will create the continuous smooth polyline passing through that point. Spline is used in most of the consumer products to show their stylish structure. I would like to create an overlay of mouse. I need to create a top view of the mouse. What I will do, I will go and say spline. I'll select first point, second, third. You can see here, and select a point here. The arc will be created exactly passing through this point, and we got the shape of the mouse as we required. And this is all about spline. Spline, still we have number of controls like showing curvatures. You can show whether it has continuous or not, and you can also edit this spline by defining the control points for defining angles, handles, and you can proportionally change the shape of the entire spline. And to edit the spline, we have dedicated tools for editing the spline, like spline tools. If you go to insert spline tools, we have number of commands to control the spline. Let's see a brief about this. Spline tools. To edit the existing spline, we have to use spline toolbar so that we can avoid the going to insert menu and retrieving every time these commands. Spline tool is retrieved from this selection. Here you can retrieve spline tools, and we got spline toolbar. The first one is adding tangency control, and then curvature control, and inserting spline points. Now one command is inactive. I will use this command, and if I select a point on this spline, you can see the points are added. But as a default, we can see only first, second, and then third and fourth. But as of now, we added 2 more points here. This will help us to control this spline using these points. And other commands can be retrieved by selecting the spline. Here you will get add tangency control, and now if I select a point on this end, you will get a tangency control handle. Using this, once again you can change the shape, or you can have one more additional advantage like curvature control. You can have a point on this. Now this will act as a curvature control to control this spline. So one will give you tangential control and one will give you curvature control. And after completing this, now if you feel it is not actually properly distributed, what you can do is you can simplify the spline by selecting the command simplify. Here you will have simplifies spline. Currently you have in original 8 points, in simplified 8. You can make smooth, so that you can see here still the spline is becoming smooth, so that you can avoid the uneven. And I will click S here. Now you can see the spline has become smooth by simplifying tool. And once you complete this, you can look this curvature. That is, if you want to understand whether this curvature is having continuous or it is having the minimum radius at the corners, by selecting this minimum radius. So this will give you the concavity of selected spline, and this will give you the minimum radius where it is in this spline, that is the smallest radius. And one icon will show you the curvature, the continuation from one end to other end. Using all this, you can control the spline shape. And apart from this, we have one more tool called as spline tool. What you can do is, now consider we drawn first line segment, second, and then third. Now I want to convert this line segment into spline so that I can change the shape according to my need. What I can do is I can go to fit spline, select this fit spline. So select the line segments, you will get the fit spline. Here we have closed spline, so the spline has covered these 2 points. Now I can use this tolerance to understand the curvature, that is the spline which we are going to impose on this line segment should have a minimum radius of 69, or what do you require. I'll click OK here, and now let's look into this geometry. Now the spline has been created, but this spline will have only will not have more control points. What you need to do is you can select this simplified spline, and here you can see in original it doesn't have anything, but in simplified it required 10. You click smooth here. Now let's click OK here, and now let's see the option available. Let's see the segments available on the spline. Now we got more points on the spline, and using this right now you can modify this shape according to your requirement. And this is all about creating a spline and editing a spline. Now let's look into the next topic. It is equation driven curve. Equation driven curve in SolidWorks has 2 types. One is explicit and next parametric. Explicit will allow us to create 2D driven curve, and parametric will allow us to create 3D driven curve. In explicit curve, the curve is created by defining the range by using x values, and the y values are calculated along the range of x values. And in parametric, t values will define the start and end of the range, and the equation for x and y are given and solved by range of t values. Let us see how we can do this in SolidWorks. My first equation is in 2D sketch using sketch, that is equation driven curve. Select the front plane. Now the plane is not oriented, I will use normal to view. The plane is oriented normal to the view. The next step is, I would like to say from 0 as a starting and ending should be 20, and this y of x value is sine of x. Now you can see the curve generated here. It will give you a sine curve, and if I change this sine as cos, now you can see the curve generated in a different way. It starts from the upward, we call as crest, or we call as crest. From there it starts. And next I would like to show you one more interesting feature, that is parametric equation. Let's see how we can do this. I click OK here, and as of now I will delete this. I will exit by using confirmation center. Now let us start with 3D sketch. In 3D sketch we have equation driven curve, And now let us start with this. The first value is sine of t, and the next value is cos of t, and the next value once again I will say cos of bracket starts 8 into t, and this value is pi, and the next range is minus pi. Now if you look, we can get a 3D curvature here. Just zoom here and you can see a curve is generated. This is called as parametric, that is equation driven curve. Still you can define number of equations and you can create helical curves, or you can create the curves looks like this. Let's see one more example on equation driven curve, which is creating a parametric helical curve. I will look into SolidWorks. Now here I will change all this sign, and here I start with 0, and here I start with 50. And now next thing what I want to do is I will say sine of t, cos of t, and next this will end up with t. Okay, now you can see if I make it as isometric view, now you can see it has created an helic curve, and if I enter the value as 4 here and value as 4 here, I will make it as multiplication, and here once again multiplication. Now you can see the size of the helical is changed and the helical curve is created using the equation. That's all about equation driven curve in SolidWorks. Next, the interesting topics are points, text, belt chain, snap and grid. Points, as you know, it is used as a reference for geometric creation, and text, it is used to write the company message or company logos or component number on the product, and belt chain is used to give the relation between two sketches, and snap and grid are once again the drafting assessments for the sketch creation. Let us start with the point creation. When you need to locate points which is used as a reference, you can go to either tools, sketch entities, from here you can select, or you can choose from here command manager, and you can place the point where you require to place this. And once you complete this, you can use this point for other geometry reference. When you need to dimension, you can apply dimension between the points where you want to keep this. And once you complete this, you can use this as a reference for the other geometry creation. The next one is, I would like to show you one more interesting feature, that is writing the text on a curve or on a plane space. First, I would like to show you text placed on a plane space, that is in a linear way. I'll create a line segment like this. It is a linear horizontal line I'll create, and I will create one more line segment, that is it should pass in this fashion. And the next, I would like to place a text. I'll go to sketch entities, text, and here you can see the curve. Select the curve and the text what you want to write here. I'll type the text and I will use the font size. I need to increase it, so small in size. Now you can see the size has been increased. Still, if you want to increase, you can increase this. And the same, if you want to place it on the top curve, you can use it. I can remove this and I can see this is my curvature. Now you can see it is placed on the spline curve, and this text can be reversed by using the options available in this property manager. Once you complete the sketch, this sketch you can use it for the extrude purpose. I will make all this to be a construction geometry, and this you can use it for the extrude, that is feature creation. I can go and say extrude this, you need to select from this feature manager tree, and I can say this sketch has to be added as a material, used for adding material. Now you can see the same text has been converted into a feature by adding material to the sketch. This is how you can type the sketch on either a curve which is horizontal or the curve which can be like a spline. That's all about text. Now let us go to the built chain creation. Almost in all the mechanisms we required the relation, that is, if I rotate the motor or the pulley, the other pulley which is connected to this pulley has to rotate, and this we can show it in the sketcher environment as a layout sketch. That is the concept. Now this is my circle, and I will say this should have 80 mm diameter, and I will say one more line. This is my line segment, and I will say one more pulley which has to be driven by this pulley, and this is, I will give you one more option. This is one more line here, and give a diameter of 50. And next, this two line segment, this circle and this has to become two separate blocks. Select this, you will have a callout manager, use make blocks, give done here. Select this, make block, done here. And now let's go to the sketch entities. Here belt chain, select this first and second. Now you will get the belt, and click here OK. And now if you drag the one entity on the other side, the other will also get rotated. Similarly, you can give different pulleys. You can add more number of pulleys and the drive can be given. This is all about belt chain relationship. The same belt chain relationship can be given between two components in assembly, where this slide will give you an idea. In this slide you can see in the sketch environment of assembly, this yellow color indicates the belt chain relationship between the different components. When we are assembly, definitely I will explain this in detail. And now let us look into the snap and grid, which is most important for creating sketches. If you want to enable different snaps like endpoint, midpoint, everything you have to activate from here. As a default it is in activation, but still if you want to specifically select endpoint, midpoint, now I will show an example. Now I created a circle. If I draw a line from here to here, it is not able to snap exactly the tangent point. Here I can go and say tangent snap. If I go here, it will show only a tangent point. This is how we can use quick snap to get only the required snap point there. This is one. If you want to create a different layout, or we can say if I want to create more complicated sketch where the increments, the dimension increments are 20, 20, 30, 40, and then I can in this situation I can use grid controlled. Means I can enable a grid. I will enable grid by going to view menu. I will say grid, and the grid is in later. This grid spacing can be controlled by using tools, options. Here go to relation and snaps. Here you can see grid. Using this grid you can control the grid whether it is used for snapping or not. I'll go to line, and if I go here you can see it will automatically snap to the line segments. Using this you can create sketch required for the feature creation. And if you don't require snapping, you can go and say grid snapping. And now if I go and create a circle here, but still it is inactive because one thing you need to go to tools, options. Here you need to go to sketch and relations. Here you have to deactivate snap only when grid is displayed. If I deactivate this, now you can see when I go and create an entity, it will not snap you. This is how you can activate and deactivate a snap grid, that is snapping to the grid. You can deactivate once again, go to view grid. Now the grid has been deactivated. This is how snap and grid can be used in sketch environment of SolidWorks. In last session we had completed sketch entities and we had seen how to create an entity. Now we are going to see how the created entities can be trimmed, how it can be multiplied by using sketch tool. The first one is fillet. As everyone know, it is used to remove the sharp corners by applying a round on the sharp edges. Here we have two options in fillet tool. One is keep constraint corners, the other is dimension each fillet. Keep constraint corners means when you fillet two edges, it will not remove the constraints applied for the corners. And if you use the option dimension each fillet, when you select when you select any corner, for each selection it will add you the fillet. And under chamfer we have three type of chamfers, and chamfer is nothing but creating a beveled face. In sketch, if you say chamfer, creating an angular line over the corner, and offset is used for offsetting the line, that is copying the line to a specific distance. And this picture will give you an idea about how the fillet is dimensioned and how the chamfer is shown for a sketch. Here you can see distance into angle, once again angle into distance, and here you can see distance into distance, and it is showing the equal distance, that is distance to distance will be same, that is it can be represented as C25. And offset, here one single entity, that is straight, this entity is offset, this offset using this offset command. Let's see these three commands in SolidWorks. The first one is fillet. I would like to show you how to apply fillet in SolidWorks. Select the fillet command from tools, sketch. It is tools, sketch tool. From here you can retry fillet. I will select from this area, and now I can apply a 10 mm on this corner. If you go near to this corner, it will give you the shape of the fillet. You can pick here and right click over on this, you will get the radius on the corner. And if you don't require if I want to create a fillet on this edge and this edge and this edge, and if you give a right click, you can see the radius only on one blend, but I need to create on all the edges. How we can do this? What I can do is I can go and say fillet. Here I will use dimension each fillet. Now if you select the corners continuously, you will get the radius on all the fillets. And now let's do one more thing. What I will do dimension for this line as 25 mm. Now when I go and fillet these two line segments, now we are going to remove this constraint 25, and that's why if you select this and if I give right click, you can see here keep constraint corners. When I select this constraint will be maintained, this 25 will be maintained. Now what I will do, I will cancel this. Let's see the difference on this fillet. And the same here, I will remove this keep constraint corners. I will select these two edges, and now you can see a warning message will be shown that do you want to continue means that you want to delete the relations, or you want the geometry relation has to be deleted. That's what the message shows. I will give S here. Now you can see OK, and this 25 has been removed. This is all about keep constraint corners. Once I complete this, in the same sketch I would like to show you the command offset. To retrieve offset, I will choose from this. Here I have 10 mm. I will select this one line segment, but you can see all the line segment connecting those one line segment, all the entities connecting those one line segment is offset of a distance to offset to a distance of 10 mm. You can change the direction by using reverse. If I uncheck this select chain, you can choose only the required entities. And if I choose bidirectional, both the direction you will have the offset entities. And if I choose make base construction, this line segment will become a construction line. Now you can notice how it has been created. And this is how we can use offset entities. And there is one more interesting feature. If I use an open line segment like this, and in this open line segment I'll go and say offset. I'll select this line segments and I will say this should have an cap ends. Now you can see the end line segment will have caps. Click OK here. Now the line has been offsetted and we have end caps at the ends. We have end caps at the end of the line segments. And now let's complete this by doing the chamfer operation on this offset entity. So I'll go to the chamfer command. Here I will retrieve sketch chamfer. We have angle, distance angle and equal distance. I'll go to angle distance 10 mm. I'll make it as 2 mm and I'll select this corner. Okay, we are not able to see it very clearly. Now what I will do, I'll increase this as 10 mm and I'll select this one. Now there is one more need. Now I don't require this 10. Once again I need to cancel the command, not required. You can do undo. If you do undo, there is a chance of reducing the mouse travel. Once again going to the menu, selecting the command. I'll make it as 20 and I'll select this edge. And I'll make it as 5 mm or 10 mm. I'll select this edge. Completed. The chamfer can be applied in terms of angle into distance, distance into distance and equal distance. This is all about fillet, chamfer and offset in SolidWorks. Sketch tools continues. First command is convert entities. Convert entities is used to convert the existing reference edges into an reference entity. You can see in this image, I want to use the existing edge of this bottom feature on this plane. Now what I did is I selected the command called as convert entities and I selected the edges over this plane and this entities has been created. This we called as convert entities, and this symbol will give you an view it is convert entities. Once you complete all this, there is one more powerful tool in SolidWorks, especially for sketching, that is trim. You have a number of trim tools available in Sketcher environment. You want to use power trim, which can dynamically and randomly can trim number of sketches, and corner trim will give you an option to do both corner and extend. Trim away outside, trim to closest. And here you can see an example and picture which will give you an overall view about trim to closest. Now let's see this in SolidWorks how we can do this. I will delete this sketch entities and I will create one more sketch on this face, and this will be using for the convert to entities. I will use this to create a model, that is I will add a sketch over here, and what I will do as of now, you just watch how I'm just using the command convert to entities, and here the plane has been created. Over this plane we are going to sketch. Go to sketch, and here what I need to do is I need to use the existing edges over here for my next feature creation, or I can choose I need these edges for the other sketch creation. Now what I need to do is select the edge or go to the command first and select this edges. If you select these edges, you can see here you have the option of select chain, so that when you select one edge, the complete edge will be selected. And now what I will do is I'll select this whole face and click OK here. And if I click OK here, you can see here the entire edge has been projected as a sketch on this plane. This is convert to entities, and this is applicable only for the faces, that is planar faces. And when you want to project the silhouette edges, we want to use the other command, that is intersection curve we have to use, and that's the only way of getting the reference edge based on the silhouette edge, reference geometry based on the silhouette edge. The next command is trim corners. Let's see how we can do trimming process in SolidWorks. I'll go and choose front plane. I will create sketches and I want to trim this. I'll go and create the I should create the sketch where I need to trim something. Now we are going to trim the sketches. If I draw something wrong, means I didn't close it properly and we want to trim, and let's see how we can do this. To activate trim command, you can get from here trim entities. We have power trim. Using power trim, what you can do is you can randomly drag this cursor and you can trim this. This is one way. And the same trim command, if you use power trim and if I choose this line segment, if I move this, you can see it will extend up to this edge. This is also possible in power trim. And let's see one more method of doing trimming. I will use corner. If you use corner, you can see the sharp corner is there. If I select these two edges, you can see it will be closed. And if I use these two edges, that is these edges, exactly the extending edges will be trimmed. And now let's look into one more process, that is trim. And I will say I don't require this one, that is inside one. Now what I will do, I'll create the intersection line segments. Here I create one more line, and here one more line, and here I will require one more line. Now what I will do, I'll go to trim. I will say trim away inside. First you need to select two boundaries, this boundary and this boundary, and I can just select crossing polygon. You can see the edges entities will be trimmed. And when you go to the same trim command, you have trim outside, trim away outside. I'll select these two entities and I will select in this way. You can see the outside entities will be trimmed. Okay. Here it is not intersecting, correct. And next let us look into trim to closest. Trim to closest, as we've seen in the PPT itself, if I use trim to closest, you will have exactly the option of going to the nearby point, and there you can trim this. This is the different trim option available in SolidWorks. And with the continuation of this, I would like to show you the interesting extend entity tool, which will help you to exactly extend. If you have any closed, or if you have the boundaries, definitely the entities will be exactly extended. And this I have to extend, and this I have to extend, and here I want to extend. So extending an entity is easy. And when you create any line segment, say I have a line segment like this and have a line segment up to here. Now when I go to extend command, it will give you an option how much you can extend, up to which boundary. If I say this I have to extend up to where, I can say up to here I can extend. So this is how we can do trim extend in SolidWorks. And now in sketch tools, we are going to see split, jog line, mirror and construction geometry. As you see in this image, this is showing creation of a jog line from the existing line segment, and here you can see a line segment is mirror about an construction line or center line. Now let's see how can we create these things in SolidWorks. I'll go for new file. Here I would like to choose front plane, and first task what I said is there is a circle and I created one more rectangle here, first corner and then second corner. Now my task is I would like to split this circle into two. Do I need to trim it by constructing any construction lines and then I can do it? Not required. You can go to sketch tools, split entities. You can select the circle entities. I'll select this one, and if you require you can select this endpoint. Yes. Now if I go and trim this, you can see here you can exactly trim the entities where it is splitted. The next one is, let's see how can we trim the elliptical, that is ellipse. And here once again I need to trim this. I want to convert the single ellipse into two. I'll go to sketch tools, split, select these 2 points and cancel this. Now if I go for trim, you can see only the half of the ellipse is trimmed. This is about split line. Next let us look into jog. Jog is especially used in the sheet metal works where you want to create intermittents. I will go to sketch tools. Here I have jog line. You select the horizontal line. You can add horizontal vertical segments here, and this line segments will be created with the perpendicular and horizontal relationship and parallel relationship. So you don't worry about applying once again the geometric condition for these entities. The next one is mirror, which will reduce our task when you create symmetric objects. First I will create a center line, then I will go and create the entity on the other side, and this entity has to be mirror on the other side. What I can do is I'll go to mirror, select these entities, and if I click a right button on the mouse, you can select the center line, and once again right click to complete the task. This is how we can mirror the entity on the other side. And there is one more interesting in SolidWorks. When you create sketch in the same synchronization, you can create on the other side also. Means like if you want to create symmetric geometry, you can go for dynamic mirror. All what you need to do is go to sketch tools, use dynamic mirror and select the center line. Now the command is in process. Go and create the sketch what you need on the one side. Definitely the other side will also copy the same, or I can say mirror the same entity. This is how you can do mirror and dynamic mirror in SolidWorks. These are the enhancement in SolidWorks which will reduce our task as simple as possible. The next task is, I would like to show you how we can convert this circle into construction geometry. You can select the circle, use for construction and click outside. And when you create any elliptical shape, I will create an elliptical shape here, and this elliptical shape has to be this ellipse has to convert as a construction geometry. Select this and use for construction. Yes, it converted. This is how you can convert an entity into construction geometry. And we'll look into the other points we had to cover. Yeah, we had finished the topics in this slide. Make path. Make path is used to create machine layout sketches. We are going to show the relationship between two components in Sketcher environment. Let's see this in SolidWorks, how we can create the path relationship between two components. Here is a sketch which shows an cam and a follower which is driven by make path relationship. Let's go into the software, and I created some sketches already, and we are going to apply path constraint and we are going to see the change. My first job is to convert these single entities into one single path. I'll go to make path, I'll select this entities. It should be tangential and moreover it should be continuous. Created, and this I will make it as a one single block. It is one single entity. And once again I'll go to sketch tools and then make path. I will select the bottom for cam and I will choose OK. And once I create this, I'll select this and we'll make it as a block. Now we given a path for we are given the path should be continuous and we are converted as a block. The next stage is, I would like to say this is fixed. Okay, and you can view the relations what we applied here. Now if I drag this top follow here, it is not right now moving it. What I need to do is I will say this and this arc segment should be tangent. Now once this relationship is applied, if you drag one cam, the other will also follow the same path. And this is all about creating a path and understanding the machine layout. And now let's switch back to the stretch entities. Move, copy, rotate and scale. How we can do all this in SolidWorks. And this entity will show you how you can stretch linearly, how you can do rotate, how you can do mirror, everything. Now let us go here, and here I will close the sketch. I will go and say new file. In the new file I want to stretch. I will go to front plane and I will start to create an entity here. Once I create this entity, I would like to stretch as per my requirement. And I will choose circle over here, and I will say it has to be trimmed. And now we need to stretch this. Go to command stretch using crossing polygon. Select this, right click my first point here and a second point up to where you want to stretch. Or you can also input XY method, means the delta X and delta Y value. I will make it as 20 and give tab, and if you use repeat you can just increment the value and you can see this. This is all about stretch entities. Now the next topic is move entities. I would like to move this group of entities from one location to other location. We can select the entities first and you can go to the command move entities, or first you go to the command and you can choose the entities. Now I had selected the entities. The first one is you can enter value by giving delta X and delta Y, or I can choose from to, that is I need to choose from point where you want to locate this. And when you are moving it, you have one more advantage of snapping the endpoint also. Once you complete this, there is one more need. I need to make multiple copies of this entity. I'll select this. I'll go to copy entities, select a point here. I will make a point here. Oh, okay, I will use XY, and here I will say 20, and Y I don't require. I will use repeat. You can see here how much increment you need. You can enter here and you can make a copy out of this and click OK here. The next step is I would like to rotate this and I want to scale this. Rotate, select this entity, or you can select this whole entity and you can say this is my origin, and you can just rotate this. Which angle you need, you can rotate this. And once you complete the rotation, you can right click, or you can choose this option to drag and to place the angle which you need to rotate. And once I complete this, I would like to reduce the scale, which is used in most probably when you want to apply machining allowance. Here in sketch we need to reduce the scale proportionately with the existing sketches. You can go to scale entities, and this is my origin. Which origin I want to use with this origin, and I will say it should be 0.5. We can see it has been reduced, and you can use copy so that you can create number of copies required. I'm sorry, we need to make it as 1.5. and now you can see if I increase the numbers, you can see the intermediate copies will be created. 2. Which one I need? I need only 1:1.2 ratio, and this to be only one copy. Use only one copy and click OK here, and it has been copied here. This is all about moving an entity, copying, rotating, scale and stretch. Almost what you do in the drafting software, everything you have in Sketcher in front of SolidWorks, where you can perform any type of complex sketches. Now the topic's sketch pattern. In SolidWorks you can create linear pattern, circular pattern, and once you created it you can also edit both linear and circular pattern. And apart from this, in the same slide we are going to see how we can edit the existing polygon also. Linear pattern and circular pattern, the advantages, we can reduce the repetitive work as you want to create number of slots required for a solar panel, or you want to create number of slots to be placed on a alloy wheel for creating the provision for the spokes. These are the different areas where you require the sketches to be copied in a linear or in a circular fashion. Let's see how we can do in SolidWorks. Now this is an layout. I want to make a multiple copy of this slot in linear direction. I select the sketch. I'll go for a linear pattern from here. And now as a default we can see x-axis has been selected and y-axis has been selected. What you need to do is you need to enter the value for this 20 mm. No, I required 30. No, yeah, 30. I think it's optimized. And now you can enter the number of copies you require. And once you complete this, you can also input the angle for this, or you can choose number of copies here. Once again, y direction 2, and here I will enter the distance as 20 mm. We'll make it as 15. Yeah. Now I'll make it as third and fourth copy. And here you can see we have the callouts where you will be able to understand, or you can also input the values here. I need only 5 instances. We can do it. Now it is processing actually. We have entered 5 instances, or you can also enter from here. Both the ways you can do it. I'll enter from here 6. And once you complete this, you have the option of giving dimension angle between the axes if required. If not, you can leave it here. And you can also add dimension between x spacing and dimension between y spacing. So the distance between two consecutive points in x direction 30 mm and in y direction 15 mm. And once you complete this, you need some of the instances in this feature is not required to show. You can go and you can select this instances to skip, and you can instance the intermediate instances and click OK here. Or you require, once again you can select this, you can add once again those features if required this one. This is how you can create a linear pattern in SolidWorks. And once you complete it, it is tough to edit this sketch pattern. But in SolidWorks you can once again select this pattern, go to tools, that is sketch tools, go and say edit linear pattern, and once again you can change this entire pattern by editing the number of occurrences and also the distance what you entered here. I need 20 mm. Yeah, you can do it. This is how you can create linear pattern in SolidWorks. Now let us look into circular pattern. I will create an circle here, and I would like to create a representation of a turbine blade from the top view for an instance. Select this one, and I will choose one more thing, and now I will say there is one more circle coming over here. I will be stamping a circle on this location. I think I had to place it up to here. Trim this one, this and this. Now we need to create multiple copy of this sketch. Select this, go to circular pattern. A point is already selected here, but I would like to change to this center point, and the point has been selected here. Now what you need to do is we need dimension radius. If required, you can enter here, and dimension angle spacing. If required, you can add equal spacing. And I would like to have number of copies to be 5 or 6 or 8. How much you need, you can add here. Equal spacing, if you remove, then the number of copies what to enter, I mean it is 30 degree, then you can see it is located, it is incremented in 30 degree for 6 instances. You will make it as once again 360 I will use equal spacing and I'll make it as 360 here. Now you can see the six copies are arrayed in a circular fashion, and you can see there are 6 numbers. And you can also use dimension radius so that you can show the same way. There is one more option, that is instances to skip. You can select this. If you want to skip, you can skip this. And now let's see what is this dimension radius. I will check this dimension radius and click OK here. Now you can see this is what the dimension radius. It will show you the dimension and it will be created. And this 6, once again you can double click and you can edit so that the number of copies will be created. So these are the user-friendly way where you can create circular fashion of sketches in SolidWorks. And once again, if you want to edit the circular pattern, select this pattern, go to Tools, Sketch Tools, and Edit Circular Pattern. And here you can choose, if you don't require it, you can reduce this to 4 numbers and you can say OK, it will be reduced. If you want to hide any instance, you can hide it. That's all about sketch pattern in SolidWorks. In the last session we had seen creating patterns, and right now we will see how we can edit the existing polygon. Means I will create a polygon here, and now I will go and create the other sketch entities required for my profile, and I will apply all this. Once I applied all this, my intention is, once I complete this, I feel this polygon should have only 3 sides. Can I select this and edit? No, we don't have option here. What you can do is select this polygon, go to Tools, Sketch Tools, you have Edit Polygon, and once again you can reduce the number of sides here, and you can see. And now let's see the reflection over on this polygon. And this is how you can edit a polygon. And this is one example of editing polygon. The next topic is, let's see how we can create sketch picture in SolidWorks. That is how we can do reverse engineering in SolidWorks. To do this, first one you need to do is go to Tools, and here you have in add-ins you have to activate this auto trace. Once you activate this auto trace, you will be able to trace the existing sketch. Once you go into any plane, any working plane, go to Tools, Sketch Tools. Here we have Sketch Picture, and I will select this Print Front View. That is front view of a car. I will place it on this plane, and you can control the image clarity here using full image transparency. You can control, or you can make it as a none, or you can go to user defined and you can choose the matching tolerance, that is transparency, color, what do you need, you can control here. And this is flipping the direction of this. If required, you can change this, and once again the direction how you want to locate this. And once you complete this, click this next button. You will be able to see lot of options available to trace this image. First, you can control the image brightness so that it will be easy for you to trace the sketch. You can control the image contrast. You can make it as high and you can make it as low, what you require, color tolerance. And once you complete all this, here we have different type of selection methods. Select rectangular area, and then freehand area, and we have polygon areas. Now what I will do is, I will go and say this shape has to be extracted. I'll go and say use select areas, and I will choose a window over here, and I'll say begin to trace. Now let's see the difference here. Oh, it has created on the existing sketch, it has traced some entities. Now click OK here, and when you exit this, you'll be able to see the sketch. Now let's hide the sketch, and I'll go and hide the sketch, and let's see the sketch traced over the picture. And using this picture, you can once again extrude using the commands available in SolidWorks environment. This is what sketch picture. This is one type of converting the existing images, pictures into the real models. And there is one more approach we can see here, that is creating a sketch on the picture itself. What I will do is I will once again have this sketch, and here I would like to say I need to create a sketch by just tracing over the. I will go and say next. Here you select, here I can cancel this, and you can very well go to the spline command and you can just draw over this spline. Select this plane, front plane I have to select. Here I can go and use exactly, I can focus this and I can draw over this profile. This will avoid the process involved in assuming something and creating something. This will give you an overall view on the design of any component. Similarly, you can create number of models in SolidWorks using this auto trace and also using sketch picture. The next topic, check sketch for feature. The next interesting topic is check sketch for feature. This is an intelligent feature in Sketcher module of SolidWorks to understand the created profile is suitable to create a feature. Area, hatch and fill is used to show sectional areas in Sketcher environment if required. Modify sketch is useful to rotate, scale up the entire drawn sketch to a degree or to a distance. Close sketch to model is useful in SolidWorks to close the open loop without drawing the sketch. Let's see how we can do this in SolidWorks. This is the drawn profile, and now I need to evaluate this profile can be used to create extrude. Let's see how we can do this. As we look into this sketch, we know that this is exactly completed and there is no any error or any mistake in this profile. But let's go and see whether the software detect the mistake what we did for creating the extrude. I'll go to sketch tools. Here I have check sketch for feature, and here I will say base extrude, and if I use check it will give you a warning message. I'll click OK, and here you just give the gap as 2 mm and use this magnifying glass, and it will show you the area where there is a small gap, that is we given 2 mm. Smaller than this gap will be shown there, and if there are number of problems it will show 1 of 1, 1 of 5, 1 of 6. So you can understand how many issues you have. Everything will be shown using this repair sketch, that is check sketch for feature. And now what I can do is, with keeping this command inactive, I can drag and I can close this, and now this command once again you can go and say sketch tool, check sketch for feature. If I place it as base extrude and check, now it says the sketch contains 2 closed contours and 0 open contours. Now this is suitable for creating extrude. This is one case. And next we have one more challenge. I drawn the sketch in horizontal orientation, but I need this whole sketch to be in some degree. It has to be in 45 degree, or I need the same sketch as a whole, it has to be scaled to the ratio of 0.75. Go to this tools, sketch tools. Here we have modify, and using this modify sketch you can modify the existing sketch or the imported sketch as a whole. Here in the degree I will make it as 45 degree. You can see the sketch is rotated, but when you look here you can see rotation is done in a default orient. I mean it takes some origin and it rotates about its axis, but I need some specific origin. How we can do this? Go to tools, sketch tools. Here we have modify, and you drag this and position where you want to keep this. And now you can use right button to say you want to rotate in which direction. You can use this and you can rotate this, or you can enter the angle how much you required, or you need to scale this, you can do this. And you want to move the origin, yeah, you can do this. X value and Y value, I'll make it as X value to be 20. Now you can see X value, I mean it is moved in X direction, and this gives the absolute the distance travel from where the origin point you had given here. Close this, and this is how we can modify the sketch as per our requirement. And now let's see how we can apply the area hatch or a fill for the required closed loop. Go to tools, and in the tools you have area hatch and fill, hatch, solid and none. I can use hatch, and if you select this area, if it is closed loop, the area will be hatched. I'll use okay, I'll select this, click OK here. Now what I will do, I will once again go back to the initial condition, and then I will continue this. Go to tools, here I'll go for area hatch fill, select this area, and I'll say this has to be scaled. It means if I give 2 here, you can see it closely looks. If I make it as 5, you can see still it is densely populated. I'll make it as 0.5 white spacing between the lines. I can also use solid fill, and I can say the color should be magenta, and I'll click OK here. You can see the hatching is done using solid fill. And this is especially not used in many of the locations, but if you think any sectional area, any important area has to be highlighted in the sketcher model itself, you can use this area hatch. And moreover, SolidWorks gives you an environment where we can also use sketcher environment as a 2D drafting environment, and you can use most of the tools available in the 2D package. The next topic we need to see close sketch to model. Close sketch to model, let's see how we can do this. I'll click OK here, and using this I will add the material, and once I complete it, let's see how we can do this later. I'll drag this, and I'll go and create a sketch on this face, and I'll say I have to create a profile like this. But here I'm not going to draw this line to complete this to make this sketch to be closed loop. I leave as it is open, and you click confirmation corner. Now if we go and use extrude command, you can see it will ask you an option, close sketch with model edges. You can reverse which direction you want to create the feature, and click yes here, and you can see it will give you an option of creating the sketch with close sketch. This is with the execution of the command. Without the execution of the command also you can do this. Let's see how we can do this. Now I'll go to the same sketch, and here what I will do is I'll go to tools, sketch tools. Here you can go for close sketch to model, and you need to define the direction, which direction you need. I'll make it here yes, and click OK. Now you can see in the other direction the sketch has been created as a closed loop. Go to extrude command, and if required apply draft and increase this, and click OK here. This is how you can use close sketch to model when you create the feature. So this avoid the major task required to create the entire closed profile, and the software itself is giving you an idea, and it is giving you an intelligent tool to close the entire open loop. Blocks. Blocks is used to freeze a subset of entities as a whole unit so that it will be easy for a user to manipulate as a single unit. And apart from that, if you want to manage complex sketches, as you seen in the last sessions, creating a sketch required for make path. When you required the make path to be created, definitely you need to convert the cam profile to be one single block so that you can create two different blocks and you can apply the tangent made and then make path which is already existing there will help us to manipulate the two sketches. And apart from that, we are going to see how we can insert the existing 2D drawings which is available from the other CAD packages, and we will insert those drawings into SolidWorks. Let's see how we can do this in SolidWorks. I'll jump into this and I will delete this profile, delete these two commands, and then let's see how we can do this. I'll go and choose the FLUENT plane, and here I'm creating a link over here. This is my link, and I believe that I will create one more circle over here, and I will make these two should be equal. And now this has to be inserted in many locations. What I will do is I will select this, and you can use callout. From callout you can choose make block, or you can right click here, you can go to block. There will be one more block toolbar is there, and from this block toolbar you can select make block and select the entities, and you can also choose the insertion position point where you required and click OK here. Now this will be converted as a block, and moreover if you want to insert, you can go to insert. You can see the block will be available, and you can see how much degree you want to rotate this, and you can place. Still the advantage of insertion point, what we given the last step, is useful for us to position this next block over this profile. You can easily snap the end point, center point, whatever is required. And there is one more advantage you have here, that is you can browse and you can get the AutoCAD drawings or DXF drawings or already saved SolidWorks blocks. This is the advantage of using block command in SolidWorks for importing the blocks, that is the standard shapes, the standard sizes and existing 2D drawings. Because in most of the companies, when they are trying to switch over from 2D to 3D, they will always have an issue in importing the 2D drawings into their Sketcher environment. But here you have the advantage of browsing, and you can select the drawing file from the external file, and you can insert here to add feature over the sketch. And that's all about creating a block and inserting a block. As of now, we have seen how to create block and how to insert the block, and now we are going to see how we can insert the drawing file into the Sketcher environment. I will go to insert block command. Here I will use browse, and I will change it as file type as DWG, and then here I will make use of this I want to click the view from here. This is my location. From here I will choose, and I'm just go opening the DWG file, and you can place where you want to locate this. And once you place this, and this will be as a single block, you can double click this to once again edit this. If I double click this, you can see this block is activated. Means you see right now we are in sketcher mode, and this is a one single block. If you move, it will move as a single unit. And the same for this case also. But if I want to edit this block, you need to select this, or you can double click, and when you select here, you can go to the command called as edit block. Here you have edit block. You select this. Now you can edit the block. Means you want to do dimension for this, you can do this. You want to modify this, you can modify this. But still, there is one more you need to do is we don't have any relation for this. You need to apply relations one by one for each and every entity. And this you have to do it more carefully when you import the 2D drawings. And if you believe that once you complete this block, and if you want to add the entities for the existing block, you select this. I'll double click, and now here I will go and say there is one more keyway I want to create. I will zoom here, and I would like to create a keyway, and I'll go and say trim. Select this power trim, and I will trim this entities. And once I complete this, you can see here we have this is adding and this is updating. I will use save. This is for saving as a separate block if you want to insert similar blocks in the other drawings also. I don't want to save this. I will just update this. Or what I can do is, once you complete this, you go and say finish. Now you can see this block has been updated. Now if I go and browse this, you can see the same block. You can see the existing, the next what you repeat to insert, it will be updated with this similar profile. And this is how you can create block in SolidWorks, and you can reduce the repetition task, and you can also create some standard libraries for blocks. And once you created this, if you believe you want to make this single unit as a separate entities, you right click here and you can get explode block. If you choose explode block, then this entity will be, this single unit will be separate entity. This is all about block. And saving block, as I told, if you want to save, you can save it as a separate block using this icon. This will be saved as a separate block in a specific folder, and you can retrieve in n number of times. That's all about block. Dimensioning. Once you created the sketch using sketch entities, you will edit using sketch tools, and next you want to apply dimensions for those sketches. In SolidWorks we have smart dimensioning, horizontal dimension, vertical dimension, and ordinate. And for the sketch you can apply the dimensions automatically, which will make the entire sketch to be fully defined. Let's see how we can do this in sketcher mode. SolidWorks environment. Here you can see the different type of dimensions. Smart dimension help us to create dimension according to the geometry creation. If I select this vertical line, I will get linear dimension. If I select these two lines, I will get an angular dimension. And if I select this circle, I will get a diameter dimension. If you select arc, you will get radial dimension. This is what we can do with smart dimension. Let's see what are the different options available in dimensioning. To retrieve dimension, I will use a shortcut, and I will make this line to be dimensioned with a linear, and select here you will get the dialog box. In this dialog box you can see here there is a variable that is a primary variable. This is very primary name given for the sketch, and you can use scroll bar to increment this. Now the increment, you can see it is incremented in 10 mm. If you want to modify, we can go to this pin increment, you can enter the value and that will be the increment value. And there is one more option, mark dimension to be imported into your drawing. When you want to retrieve these dimensions in Sketcher, if you want to when you want to import this sketches into the drawing environment, you need to select this button, and once you complete it, you can give here done. This is about smart dimensioning. Once you complete smart dimensioning, the dimension properties can be controlled by using this dimension property manager. Here you have the option of adding the prefix for the dimension, or you want to apply tolerances, you want to apply limits. What do you need, you can apply here. I'll make it as 5 mm here, plus you can see the from the size, exact size 5 mm will be automatically added and it will be shown. You want to align, you want to add any special prefix or suffix to this text, you can do it. And still, if you want to have dual dimension, you can also have the dual dimension. And once you complete this, there is one more option of controlling the leaders, how it has to be, which style you have to use, whether it should be inside or outside, what you want to create, you can apply from here. And leader style, if you want to if you want to make it so thicker, that is, you want to apply more line width, you can apply for this. And other, here it will give you an option of overriding the length unit. You want to show it in the millimeter or you want to show it in the meter, you can override this. That is, apart from setting up the standard units, you can also override, and for your user friendliness you can choose the required unit to be shown there. And still, you can make it as driven dimension or driving dimension. If you make driven dimension, this will be the reference dimension. This will not drive the geometry. You cannot edit this. This is all about smart dimensioning. Now let's look into baseline dimensioning, that is ordinate dimension and then vertical dimension. If you go for horizontal dimension, if I select these two center point of the circle, you will get horizontal. And if I go and say vertical, if I choose these two circles, you will get the vertical dimension. And if I choose ordinate dimension, and I will say this is the baseline, and I will say this circle and this circle, this is ordinate dimensioning. The same like I can do horizontal, select this origin, and I will say here second, third and fourth entity. Now similarly we can create for vertical also. I can select this one and make this has to be shown here, and you can select this to create the ordinate dimension. And once I create this, I would like to move this and keep it this dimension along this near to this sketch, but all this sketch is moving in one single unit. I need to break the relationship. What I will do, I'll right click here and I'll go and say break alignment. If I use break alignment and I'll click OK here, now you can see you can move this as separate entities. Once you did this, if you want to once again align this, select this entity and go and say tools, dimensions. Here you have align ordinate. Once again you can align ordinate. You can dimension, you can align all the ordinate dimension. And there is one more advantage you have here, that is you can make the sketches to be automatically dimensioning the entire sketch can be dimensioned automatically by the software itself, making it fully defined. Select this and go to tools, dimension. You have fully defined sketch, and when you are defining this, you can use what type of constraint you want to apply. You want to apply only horizontal, or you want to apply tangent. Whatever you need, you can choose everything here. And when I select calculate, it will give you the orientation of the dimensions. But I need on the right of the sketch, I'll use calculate. We are done on this, but once again this should be above. I'll calculate. Here you can see all the sketches has been given dimension, but it looks to be so congested. So what I will do, I'll cancel this and I'll take only one entity, that is I'll take only one sketch so that we can understand how it creates. To tools, dimension, fully defined sketch, calculate, and once again above sketch, calculate, and right at the sketch, calculate. This is how you can apply the dimension to the sketches automatically. And when you want to change, you can double click and you can change as per your requirement. That's all about dimensioning in SolidWorks. Relations. Relation is nothing but it's all about geometric characteristic. That is, the line has to be in the horizontal orientation, or the arc has to be tangential with the line. These are the different geometric characteristic we apply for the entities. That's what we call as relations. In SolidWorks we call as geometry relations. Once you create entity, you edit, you apply dimensions, and wherever we require, we need to apply geometric relations. Now let's start with the first one, horizontal and vertical, which makes us the line, if it's an angular, we can make it to be horizontal or vertical, and collinear will make the two lines to be on the same infinity plane or line, and co-radial will share the same center point and radius. Let's see the relations one by one in SolidWorks. Now I have this predefined sketch. I would like to make this to be horizontal and this to be vertical, and I will create one more circle over here and one more circle over here, and also in this area. Now I need to make this and this circle to be in the same vertical direction, and this to be in same horizontal. Now when you drag the circle, you can see the relation between these circles will be maintained without disturbing their characteristic, like changing the orientation between the two center point of the circle. The next one is collinear. Now I will draw one more line here, and I will say this line has to be collinear with this line segment. And if I select collinear, you can see here, okay, it gives you the unsolvable situation. What I will do here is I'll make this line and this line to be collinear, and if you use collinear, you can see both will be lying on the same plane. And you can also do one more thing. Say we had made this sketch to lie on this condition. Now it's in the collinear with this center point. Now I can drag and keep it over here, and I'll make dimension for this as 280, and I will complete this line segment. But now what is my requirement is I need to make this line segment and this line segment should be collinear. Now once again there is an issue. What I will do here is I will cancel this, and we have to remove this one because since it is having the relation with the endpoints. Now definitely it should work out. I'll select these two line segments and I'll say collinear. Now you can see both will be lying on the same plane. And the next one more interesting thing, that is I want to make this circle. What I can do is I will create a circle over this space, and I want to make this circle and this arc entity should share same center point and radius. You can select these two edges and you can make co-radial. Now you can see it will share same center point and same radial dimension. And now there is one more condition. I need this line and this line to be perpendicular. Select these two line segments using control points, and from this call out I will use make perpendicular. And the next task is I would like to create a line segment up to here, and there is one more line segment up to here. But I need to make an assurance like these two line segments should be parallel. You can select this. Before that we need to confirm these should have an angle of 140 degree, so that this will be fixed and this will become parallel to this first selected line segment. I'll give parallel. You can see this will be parallel. And now let's see one more constraint which we'll be seeing in the next slide. Let's see how we can do this. I'll select this point and this point, and we can make it just merge points. If you use merge, both will be as a one single point. But as you know, this will be unsolvable since we are given parallel. We cannot do this. But you can apply horizontal condition between these 2 points. This is all about making horizontal, vertical, collinear and co-radial for the sketch entities. And now let's see how we can apply parallel relation. It is parallel relation in the YZ direction and in the XY YZ direction and ZX direction. But this relation will work only in a 3D sketch. We'll go and create a line segment. I'll draw in any direction, but I want to make this line to be in to apply parallel YZ constraint. We need to select this line segment and we need to select a plane, and here you can get parallel YZ and parallel ZX. Which one you need, you can select here. Accordingly, that will be parallel. It will be parallel to the selected plane. This is what we call as parallel YZ or parallel ZX. We can also define one more constraint, that is along X, along Y. If you choose along Y, it will be oriented along Y direction, but I don't require Y direction. I will choose this and I will say it should be perpendicular to this, so I need to use along Z, and this has to once again along Y. Now you can see we apply couple of constraints for the 3D sketch by defining the direction in the parallel YZ and parallel ZX and along X and Y. This completes this slide relating the constraint with respect to the geometry. The next relations are tangent, concentric mate, midpoint, intersection and fix. Tangent is used to apply the tangent condition between arc and then line, or arc to a spline. Concentric relationship will maintain the center point or the arc to be on the same center point. That means the selected arc or the circle will share the same center point. Midpoint will make the selected point to be placed on the mid of the selected line entity. Intersection will make the point to be lying on the intersection of two entities. Fix, as you know, it will fix any point, that is any one single point or the whole entity. Let's look this in SolidWorks. I'll cancel this. I'll go and choose the front plane. Here first one is, I will start like this and I'll make a line arc over here and one more line here, but line segment and here, and I'll create a circle here, and I'll create and one more circle over here, or I will create one more circle on this entity. And now let's see how we can apply tangent mate, that is tangent relation and concentric relation, and let's see how this will work out. Now when I start to create this, you can see automatically there are some relations which is applied automatically to this line segment and arc. But here I need to maintain once again the tangential condition between line and arc. We can do this. That's what we did right now. This is what tangent relation. The next, I would like to make this two circle to have the same center point, concentric, and I want this circle to be placed on the midpoint of this line. I can use midpoint from this call out, and you can see it has been located exactly on the mid of this line segment. And we have one more option, that is getting the intersection point. Now I will get the intersection point between these two, and I will make a line segment up to this. And now we need to place this circle on this intersection point. I will select this center point, and I will select this intersection, that is intersection point. Now you can see because of the sketch is not fully defined, it is moving in a different direction, that is circle is enabling the other entity to move. What I will do, I will create one more circle over here, and I'll make this circle to stay on this two center point. I'll go and say intersection point. Now you can see here the circle is located on the intersection of two line segment. And now there is one more option, that is fix. What is the advantage of doing this fix? Let's look into this. I will create a circle over here, and I have the option of moving the circle where I need this, but I need to fix the circle in this location. I will use fixed, but still you will have the advantage of resizing this circle, but here you have fixed this. And if you go and fix a line segment drawn here, and if you say this point is fixed, I will remove this line segment, and I will say this point is fixed. It is possible to orient the line segment where you require to place it, but you cannot change this location. Now I will make one more line segment here, and you can see here, but the circle diameter change. I can go and say this has to be 50 mm diameter, and now I'll drag this. Now you can see here how this fixed constraint works. This is how you can use different relations in SolidWorks. Now this ends with this slide. The next slide, relations. Here we are going to see coincident, equal slots, equal curvature, symmetric, and fixed slot. Coincident, as you know, it is used to make 2 points to be lying on the same point. Equal slots, if you draw a slot and if you want to make the two slot to be on the same size, you can use equal slot. Equal, it applies for curvature, circle, and line segment. Let's look into this each constraint in SolidWorks. Next, coincident. Coincident is used to make the point to coincident on a line, on an arc, or a circle. You can make the line endpoint to be lying on the arc. That's what I mean coincident. Equal slot, when you create slot, you can make the two different slots to be having the same parameters. Equal is applied for circle and also for arc and also for line. Equal curvature is used to apply for the spline. Symmetric, as you know, to create the geometry on the one side to be the same on the other side, we can go for symmetry. Fixed slot, to fix the predefined slot on the same location. Let's see in SolidWorks how we can create this. Here in this sketch, I want to apply the first constraint called coincident. That means I need this endpoint of the arc should lie on this line segment. I can go for midpoint. No, we need to apply make coincident. The same for this on this. I'll use make coincident. Here I have one more requirement. This arc is in different radius, okay, and this arc in is different radius. I want these two arc to be having the same radius, I can use equal. Now these two radius, now if you dimension one, both radius will have the same parameter. This is the symbol which will enlight the equal. The same you can apply for the line segment. You can select two line segments and you can make equal. But here we didn't apply the constraints fully for this sketch. It is behaving in a different way, as other design intent is disturbed. The line segment is changed dynamically. And now let's look into the equal curvature, how we can do this. Equal curvature, here if you look into this diagram, I created a surface and I created a spline over here. I'll select this spline, then I'll select this edge of the surface. You can apply equal curvature, that is the curvature will be sharing, that is equal curvature. I hope it will be inward geometry. What I will do, I will remove this and once again I will create the spline. I'll go and say I'll create a spline here and I will say this surface and this should have the this first should lie on this point. I'll make pierce and I'll say this and this should have the equal curvature. Now you can see it is having equal curvature. That is if you look in this view, if you in this side view, if you see, you can see the same curvature is maintained over here, and after this point the shape is getting modified. This is what equal curvature. Let us look into the symmetric relation. I have geometry on both sides, but I have to make symmetric about the center line. Select the entities which one you want to do it, and also select using control point these entities and select the center line. You will have the option called as symmetric. As of now we did wrong selection, so I will deselect this. I will select using control key the two line segment and this center line. You will have symmetric, and this symmetric condition can be applied for two circles, two arcs. You can select the two circles and a center line. You will use symmetric. And let's look into the one more relation, that is equal slot. We created two slots. I'll select these two slots which is of different size. I can use make equal, and now I need to fix here. I'll go and say make slot fixed. That's all about relation in SolidWorks. Now we have remaining couple of relations. Let's see in the next slide. Let us look into other geometric relations available in SolidWorks. Pierce. Pierce is used in most probably swept and loft commands, where you want to align the sketch exactly with the intersection of the other sketch. Now I'll go and choose the predefined sketch which I drawn here. This is the sketch which I drawn on the top plane, and there is one more sketch I drawn vertically vertical to this sketch. I would like to exactly coincide this sketch with this one, that is where it intersects. I want to do it there. If I go and select these two entities, I will get pierce. So pierce will exactly align this guide curve with this bottom section. This is all about pierce. And next let us look into merge points. Merge points. Here I created a sketch, and this line has to exactly align with this point. Either you can drag this or you can select these two center points and you can say I need to merge. So these 2 points will be merged, or you can also use dragging the method to apply this coincident or coincident constraint. The two ways you can apply this coincident. The next one is a doubled distance, which is one more interesting in SolidWorks. When you go and detail any revolve section, we will create diameter dimension representing in this way. How? Go to dimension, select this center line, line segment and the center axis, and if I drive this, you will get this doubled distance we normally use for cylindrical geometries, and this we called as doubled distance. And the next one is offset. Offset, we normally, when we do offset entities command, we get the entities offset from the selected line segment or circle, and when you apply this command you will get a constraint called as offset. And on edge, when you use convert entities, you will have the entities copied with a relation called as on edge. And next, let's see on plane how we can apply using SolidWorks. Here I drawn a 3D sketch and I created a plane here. I need to place this line segment on this plane. I can select these two and I will say on plane. Now the sketch is exactly positioned on the plane. And now there is one more interesting. I want to locate exactly on the plane. That is I will go and say, where is my sketch? We'll go and choose my sketch from here. Here I drawn a sketch in a 3D environment, and this profile can locate anywhere, but specifically I want to locate on the surface. You select this endpoint and this surface you will have on surface. So this exactly will place on the surface, so you can locate anywhere on the surface, which means it will locate exactly on the surface. And tangent to surface, almost same what we seen before. I'll go and choose a plane here and I'll create an spline, and this has to be exactly tangent to this. I'll select these two and I'll say it should be tangent. This is a different tangent, but I need tangent to face, so I select this face and this spline. You'll get I'll get this line and this face. Let's see this command in the next interface, because this profile is not supporting. Let's look into the traction. Traction is nothing but adding relationship between two entities as two single unit. We had seen in build and chain, the same we are going to see in a different way. That means we are going to add traction relationship where two entities will mate each other and it will have the traction. So you are going to apply the relative motion between the two single block. Here we have one block, this is one conveyor, and this is one mechanism which will make the conveyor to move to and fro. That is linearly. Now we'll choose the first circle and this bottom line segment. You will get the option called as engage block, or we can make it as traction. But I need this line to be horizontal, and after applying this you can just see the traction applied on this conveyor. So that's all about relations. Let us look into one more relation called as tangent face. Sketch Expert in SolidWorks is an one shift feature in SolidWorks. It is SolidWorks Intelligent Feature Technology. It is an intelligent tool which will help the user to understand, to remove the relations applied to the geometry, or to remove the dimension applied to the geometry when it is in conflict. You can see in this slide, there is a slide which shows a rectangle having a length of 60 and width 40. But when there is a conflict, it will show in this format. It will show in yellow color, it will show in red color, and we will understand what this different color will mean in the next slide. But as of now, we have to understand what this Sketch Expert can do. Sketch Expert exactly will understand the feature, whether it is fully defined or over defined, and it will give you the option of removing the sketch relation or the dimension. and here you can see in representation which is showing the same. Now let's look this in SolidWorks. I'll go and create a sketch in the front plane, and I'll say this is the sketch. And once we start to create the sketch, I'll go and apply dimension for this. Here length of 110, and this is of 25, and this of 15, and this is of 70, and I will make this is of 60, and I'll give one more constraint as 15. And now what I need to do is I need to make a dimension for this line segment, but it gives you an representation that it is in conflict. You cannot understand which dimension I need to remove so that I can avoid this conflict. You don't want to worry about this. You can go to tools, sketch tools. Here you have sketch expert, and if you use manual repair you can do it manually, but I will go for diagnose, and here it will give you 11 different options. You can either remove this vertical or horizontal, or you can remove, you can see in this screen it will show the constraint which you have to remove so that you can avoid the situation. Now you need to understand all this, and it is showing right now 60 mm. This dimension I will remove so that I can apply this angle. And right now I click this, and now you can see, oh I'm sorry, we didn't do it. I'll go and say tools, sketch tools, sketch expert, and diagnose, and I'll skip all this, and I'll go for dimension. This dimension, yeah, I'll accept this so that you can make this sketch to be solved. That's all about sketch expert in SolidWorks, which will avoid the conflict between the constraints in the sketching module. The next topic is 3D sketch. We had discussed in short in the previous session, of course maybe in the previous earlier slide. Now let's see how we can create this 3D sketch. We have here two type of sketches. I'll cancel this. Now let's see this. We have 2D sketch and 3D sketch. You can go to 3D sketch, and here you go to line command. Which command you require, you can choose from this toolbar, and you just select the first point, and using tab you can switch over you want to create on the XY plane or YZ plane. And when you are creating this, there is one more advantage we have here. It is we can do dimension for this plane, this line segments. Means I want to create one more line segment, I can just copy this on this point. I will make coincident merge points, will make a line segment passing over here, and now you can do dimension for this. I need 85, and this is how you can create a frame for the any structural design, or if you want to create a frame for a car, whatever you need. This is I'm saying race car, you can do this one. And once you complete this, if you want to smooth the corners, you can use once again fillet commands to apply fillets on the corners. This is what the functionality. But let's look into one more advantage. When you create this 3D sketch, it will act as a one single entity. Now what I will do, I'll remove this line segment, and okay, I'll remove this line segment. And now if I go to creating a sweep feature, say I have this one single entity, and I'll create a sketch on this plane. I'll make a circle over here. Now if you look at this, if you look this one, if you want to sweep this, you can select one, and this will act as a single guide curve, and you can sweep this. This is the advantage of using 3D sketch. And there is one more command, that is rapid sketch. Rapid sketch, let's see in detail in the next slide. Rapid sketch in SolidWorks is one more enhancement tool. It allows you to select planar faces or planes with any sketch tool active, and you can start to sketch randomly. Let's see how we can do this. At first we need to activate this rapid sketch. You have the icon here, you need to activate this, and now let's go to the line command, and you can see here the planes will be shown automatically which phase you're going to draw this. And when this is active, you can go and start the line segment, line on this surface immediately. And if you don't have this rapid sketch, what you need to do is first you go and do this. If you start to do this here, you can see this. I will exit this, and now the rapid sketch is not in active. Let's see how we can do this. I'll go and say line command. You need to first select the sketch, and then you need to go and draw this. But when you activate the rapid sketch and you want to create a circle on this face, you can go and create dynamically without activating the sketch. That is, it is ready to use. It is ready to draw on any face using rapid sketch. This will help the user to complete the task as soon as possible. That's all about rapid sketch. And this representation will give you an idea how this plane is highlighted when you activate the rapid sketch. Let's see in the next slide about the different colors we get in sketch environment, and let me understand it. Let us see the different colors in sketch environment which indicates the status of the sketch. Dangling dimensions will be shown in brown color, and the driven dimensions will be shown in gray color. Similarly, we can have different representation for invalid geometry, unsolved conditions, and which is not able to define fully, that is underdefined. Everything will be represented in different colors. Now let us start with the first one, dangling. What do you mean by dangling dimension? Go to SolidWorks. Here I will use this one. No, I'd like to go to this part. No, this part. Here we have a hole located on this face. It is referred from this edge and from this edge. Now I will remove this cut, and let's see how this dimension will be enlightened with dangling. Here you can see a warning message. You right click here, you will have what's wrong with this, and it will give you there is a message which says deleting the dangling sketch entities or editing the model to restore the missing model. Now what I will do, I'll go and edit the sketch. I'll go inside, and now you can see here the brown color. This is called as dangling dimension. Now if you want to refer it, you select this, you will have a red point here. You can select and you can place where you want to refer this. Still I didn't refer it properly. Once again I refer this dimension, this red color I want to locate with respect to this sketch. Yes, I had referred properly. Okay, here now the hole is located as per our requirement. This is dangling dimension. And next let us look into one more thing, that is gray color, that is driven dimension. Now this sketch has been fully defined, and now if I try to create one more dimension between these two entities, it will give you two type of dimensions. Make this dimension driven, leave this dimension driving. So if I use leave this dimension driving and OK, it will show you the message the item is unsolved item conflicts. This gives you a different representation, which is yellow, which says it is not able to solve, and you can see here there is one more option given here, over defined. If you click this icon, you'll be able to activate Sketch Expert, and here you can go to diagnose or manual repair, and you can choose which one you want to remove this. I'll select the 60 this dimension. You can select from here and use delete, and now it is fully defined. Let's see how this gray color comes into this picture. I'm going to do dimension between these two entities once again, and here I will say make this dimension driven and click OK here. Now you can see the dimension will be in gray color. This is how you can understand the sketch status by different colors. And when you create the first sketch in the geometry without any reference, without any constraint, it look in blue color. This is what the default color of the sketch. And there is one more representation, that is here you can see, as of now we had seen black color for fully defined sketch and yellow for unsolved, that is item which is conflicting, and dangling dimension and driven dimension, and also the underdefined, the default color of the sketch. Here you can see one more image which shows the unsolvable, which is showing in red color, that is the 80 dimensions shown in red color. Here in this initial sketch you can see 50 is given as the distance between two circles, but when you increase the 50 to 80 it is not able to solve. It shows it is an unsolvable dimension. The reason is already these two circles or dimension has relation with tangential constraint and also other dimensions. So when we are able to apply this, and when you want to change the existing 50 to 80, you cannot change this. That color will be enlightened with red color. And this is all about sketch geometry status. If you know only the creation of sketch and editing of sketch and applying geometry relation and doing dimensioning without understanding the different color, that is the geometry status, you will not be able to define the fully to be parametrically controlled. And that's all about the sketcher environment of SolidWorks. I hope this session will definitely give you a better view on sketching 2D entities. To start with this, I would like to give you a small sample sketch that can be created in SolidWorks. As of now, we had seen how we can use different sketch tools, sketch entities to create a sketch. And now we are going to use all those commands, dimensions, relations, and we are going to do a sample exercise as shown in this slide. But I would like to give you the steps involved in creating this before we go into this software. At first you need to create the sketch using sketch entities, and you can trim it using sketch tool, and you have to apply geometric relations, and finally you have to go and apply dimensions. And let's see how we can create this sketch in SolidWorks. I'll open SolidWorks. I'll choose a plane from here. I will use sketch tool. The first task is I would like to create the center, which is the middle circle, which is of 50 mm diameter. And next I would like to create one more circle over here, that is just having a size of 70 mm diameter. This is 50 and 70. And next I will create one more circle over here, and this should have a dimension of one is having diameter 10, and there is one more circle here which is having a diameter of 30. And once I complete this, I would like to create a line segment, that is center axis. Go to center line, we'll create from here to here, and one more center line I have to draw it. I'll go and say from here to here I have to choose. Now you can see I was retrieving the center line by using a small pop-up window. How we can retrieve this? By pressing shortcut yes in the keyboard. And now I'll go and choose once again the line. I'll draw here, and I will say this and this point about this axis should be symmetric, and I will mirror this using mirror tool. And once I complete this, we need to do dimension between these two lines, and I will say this is 75. and this length should be 25. And now we need to create line segments. I'll go and say line has to be created from here to here, and once again other line has to be created from here to here, and next you can mirror this line segment exactly about this axis, and we can trim the unwanted entities. Before that, what I will do, I will go and say, okay, let's complete this. Let us trim this. I will go and say trim this two corners. Okay, I will go and say power trim. Here I want to use this area and this, and once again all this sketch entities I need to trim, and also this area. And we can make this and this to be vertical, and this and this to be vertical. And we need to create line segments starting from here up to here, that is, it should be tangent. So I can go and say from here tangent snap, and once again line segment from here to here. We need to get tangent snap exactly. We got it. And next I have to dimension between these two center points, saying it should be 75. And next you can trim this using power trim once again, these two entities, and we have to say this and this should be, yeah, it is tangent almost right now. Now you can see we have done this diameter, but we need that should be in a radius. Okay, and 50, it's okay, correct. And this has to be, once again it should be in the radius. But we need to understand there is a the sketch is not fully defined. So how we can understand this sketch is defined fully or not? It shows some lines are in blue and some are in black. We need to right now make this fully defined. So what I will do, I will check these 2 points is vertical, correct, and I need to make these 2 line segment symmetric, correct. But this line segment I have to make sure this line segment and this line segment about this, it's symmetric. Yes. Now if I do these 2, then my sketch is conforming, it is fully defined. Now you can see it looks black in color. Now this is fully defined, which is black in color, and it is parametrically controlled, and now you can use for feature creation. This is all about sketching process involved in SolidWorks for creating 2D sketches required for part modeling. And once you complete this, definitely you need to complete the 4 exercises given in your SolidWorks project workbook, and that should be within the stipulated duration. But once you complete this, please evaluate with your seniors or with the assistant from your other instructors to complete this task. Thank you. In this video, I am going to exercise given in your project workbook. Let us see how we can complete the entire sketch given on this page number 4 using SolidWorks. First, I will start with circle, and if you see, circle will be started with dimension input, and here I will enter 22 as my diameter, and I require one more circle which is of 78. You can see from the sheet which I shown on the right side. Now I will just go here and make one more circle of diameter 12 and another circle of diameter 22. So this is of 12. So once it's completed, I'll make sure that these 2 points should be vertically aligned, and I'll make sure that this should be having a distance of 57. So once it's completed, I'll go and create another circle on this side. Circle from here, choose a circle here, and its diameter is 36, and I require one more circle here, and that diameter is 18. So once it is completed, we need to do dimension for this. We need to apply distance for this. So I'll select these two and I'll say it should be of 104. The distance should be 104. And right now I'll mirror these two circles. So before we do mirror, we need to create a center line, and this center line should be used to mirror this. Select two circles and say this is my mirror line. Now I don't require this 57, I can remove this. Now let's go and create dimension between these two, and this is of 90 mm. So now almost whatever the entity we created, everything is fully defined. And now I can go and say line segment between these two. We don't require this 90 mm. Now I will remove this option, that is creating dimension with the entity. For this, right click, and here you can see uncheck this option. Now you can see this is unchecked right now. So now whatever the entity you create, it will get dimension. I'll go and choose an arc from here.